What's going on, guys? Assalamu alaikum. Welcome to Amigoscode. And today, because you guys have been asking it for so long, I decided to record a series on microservices. Yes, microservices. If you're new to my channel, go ahead and literally subscribe. And also, you see that like button. Just take 2 seconds and smash it. Literally, just take 2 seconds and give me a thumbs up and comment down below and let me know what other videos that you want to see. But in this video, we're going to learn about. So hopefully I will get the chance to teach you all of this that you see in here. And to be honest, this is quite interesting. And yeah, so this is what professionals do. And hopefully I will try my best to teach you everything in the best manner. Now, what I want to do first is show you how you're going to use, for example, Eureka server and config server. But then I will show you as we transition to Kubernetes that we literally don't have to have some extra services and we can just focus on what is our own domain, which is our own microservices that perform our own business logic. In this video, I don't want to go too much in depth what a microservice is. If you want to know, just let me know. I can do an in-depth video on it. But just imagine where you kind of start with the monolithic application, and as the application grows, then it's more difficult for you to deploy your application. Also, if you have a lot of people working on the same code base, then if my team wants to take something to production, it means that I will also be taking the other team's changes to production, right? Now, the microservices world pretty much just decouples things, and we can just focus on a subset of the entire application, and we can deploy things independently. We can iterate quicker. Things are not coupled. If you want to use a different database, you can use a different database, different technology, so on and so forth, right? So what I want to teach you is, so right here, this is the public internet, and as the clients send requests, we will have a load balancer in here. So this will serve as the main entry point. So we usually, when you build applications, you don't have the clients talking directly to these services right here, right? Because these services or everything in here, this should be within your private network. And then the load balancer is responsible to perform the routing to the corresponding microservice based on the path. So you'll learn all of this later in this series, but in a nutshell, so you have the load balancer. It sends requests either to these two services, and I've called it customer and fraud. And we also have notification right here. So the idea is that if a client wants to register a customer, for example, we check whether that customer is fraudulent, and this blue arrow indicates that this is an internal communication between these two services. So if the customer is not fraudulent, then we save the customer, and then we push a notification into the message queue right here, which this notification microservice can use. And then perhaps it might use Twilio or Firebase to send SMSs or push notifications. Now, all of this in here is powered by a Eureka server. So as you'll see, usually you don't want to be dealing with ports, right? So calling a service on a specific port, because if you have multiple instances of it, then how do you keep track of all of those ports? And basically, you just want to have a centralized place where all the clients register to the server. So in this case, the Eureka server. And then if you want to communicate with them, you just need the service name. And I'm going to show you how to set all of this. You also have the config server right here. So config server, this is mainly for storing your configuration. So whether it's development, testing environment, production, pre-prod, so on and so forth, right? So you'll see that in theory, we don't need even the config server, but I'll show you what it is, so on and so forth. Then we also have sleuth and distributed tracing. So with Zipkin, so this is so that if a request comes, so let's say that request gets to customer, then it flows through fraud, and then it goes to notification, then with distributed tracing, we know exactly the entire flow and where perhaps is our bottleneck. So this is pretty much the overall view. Now, I'm going to be honest with you here. So there is a lot to learn. Literally, there is a lot to learn. And usually you should just take what you need instead of implementing, for example, let's say config server or Eureka server, right? Because there are better ways of doing this these days. Usually, if you want to take your application to production these days, Kubernetes all the way, right? So then you kind of don't need Eureka server nor config server. And also you'll see that, you know, the Spring framework, they have their own load balancer. And also I would say, like, I'm going to show you exactly how to set it up, but usually you would never want to manage a load balancer yourself, and instead you pay someone else to manage the load balancer and make sure that it's you know, always available. It can also work multi-region. SSL certs are done for you, so on and so forth, so that you just focus on your domain, right? So your own business logic. The same with databases, right? So databases usually never host, or you never provision a database yourself, right? So you never have a server which you look after. Usually you just have a database as a service and then you use it. So the same will be for the load balancer, Eureka server, config server. This is taken by Kubernetes, Zipkin. There's other things that you can use, but I'm going to show you how to implement all of this so that you learn, and then I'll show you better ways of doing things. So this is all for now. Catch me on the next one. By the end, you should have a complete understanding on how to pull all of this together. Now, how exactly are we going to achieve this? If you've been following my courses on Spring Boot, then you should know by now that Spring Boot makes it super easy for you to build Java applications. So in here, in the official page of spring.io, you can see that basically what you can do with Spring. You can write microservices, reactive programming with asynchronous, cloud, web apps, serverless, event-driven, batch, so on and so forth. So you can go and basically see how to get an application up and running super easy with Spring Boot. But in this course, you learn all of this. And what I want to show you is, so right here, because we are learning about microservices, let's just see what they have to offer. So in here, microservice architecture are the new normal, building small, self-contained, ready to run applications that can bring great flexibility and added resilience to your code. So basically, you can read more about this just to have an overview. But in a nutshell, in here, the way that we build microservices in the Spring world is using Spring Cloud. So this diagram right here is the representation of this diagram right here. And basically, I've put everything together because I want to build a fully fledged system that communicates to each other with their own databases, so on and so forth. And this diagram here is much easier for you to understand what is happening. But basically, at the end of this course, you'll have an understanding of all of this. But what I want to show you is, if you click on Spring Cloud in here, so they give you, again, definition. So developing distributed systems can be challenging. And this is what the Spring Cloud project gives you. So here you can see that we have projects, we have Spring Boot, the framework, cloud, data, so on and so forth, as well as security, which I have a course on it. But right here, so again, the exact same architecture. You can see that we have service discovery, API gateway, cloud configuration, circuit breakers, tracing, testing, so on and so forth. And what I want to show you, actually, if I click on projects, let's go to Spring Cloud, and right here, have a look. So this is all the sub projects within Spring Cloud. Now, obviously, we're not going to use everything in here because, as I said, you should only really take what is necessary for you to write your own microservices. And then as we move towards Kubernetes, you'll see that some of these things are not needed. But go ahead and basically have some reading on how to get all of this up and running. but later you'll see that how we're going to install Spring Cloud, so on and so forth. I'll make it super easy for you to understand with Maven multi-modules. So hopefully now you know about Spring Cloud, and within projects, you can see that we have Spring Boot. So this is what allows us to write the microservices, and then Spring Cloud allows us to bring all these microservices together. And also you've got Spring Data for databases, Spring Security for securing your microservices, so on and so forth. If you have any questions, drop me a message. Otherwise, let's start developing microservices. For this project, we're going to use Maven as our build tool. And in this page right here, which you can find a link in the description of this video, you can see that they give you the installation guide for the operating system that you have, and then how to create a simple project. So because I'm on a Mac, I'm going to use brew. So within my terminal, I'm going to say brew, install, and then Maven. So this should take a while now. And there we go. So now we have Maven. Now, if you want to make sure that Maven was successfully installed, just clear the screen and then type mvn -- and then version. And there we go. So this is the version which was installed in my machine. So now that we have Maven installed, in here in this guide, you can see that we have this command that we can use to create a project. So we say mvn archetype generate, and then we pass a couple of flags in here. So here the group ID, so this is basically our organization, and the artifact ID is the application name. And then we pass some other arguments. So copy this command and then change this according to your organization or your name, and this as well. And I already have done that, so I'm just going to paste it. There we go. And you can see that the group ID is com.amigoscode, and then the artifact ID is Amigosservices. And in fact, before I run this, let me cd into desktop and then paste the command again. There we go. And just give it a second. And there we go. So now in our desktop, you can see that uses Amigoscode desktop. We have this folder right here. And what I'm going to do is cd to Amigoscode services. And then in here, I'm going to say ls. And this is the Maven file structure. So let me see if I've got a tree in here. No. So I'm going to say brew, install, and then tree. There we go. And now I can type tree and check this out. So this gives me now the folder structure in a very nice way. So you can see that in here, we've got the root, we have the pom.xml, src main java com amigoscode, app.java, and then the same for the test, and we are good to go. Next, let's open up this folder with IntelliJ. So in here, I do have the IntelliJ Ultimate Edition. And if you want to grab it, I would recommend you to install JetBrains Toolbox. And if you want to grab it, I recommend you getting it through JetBrains Toolbox, because this is the easiest way that you can manage all of your IDEs and perform all the upgrades, so on and so forth. So here I've got the Ultimate, and this is what you see in here. Now let me open up this folder with IntelliJ. There we go. And inside of my desktop, I do have Amigosservices, which is this folder in here. So just pretty much just click on the pom.xml or the folder, either one should work. Open as project and just give it a second while it's downloading whatever it has to download. There we go, that's done. And what I want to show you is, so let me just put this full screen. So in here, if I go to file and then project structure, I just want to show you that I'm using Java 17. And in here, if you want to use Java 17 as well, so that everything works with no issues, just click on edit and then click on plus, and you can download the JDK. Just select 17, but in here you can see that I can download all the other versions in here. So 16, 15, 13, 11, and 1.8. So 17 is basically the one which has the long-term support as I speak. So just U17, and then that's it. Next, let's bring in the dependencies that we need in order to start building our microservices with Spring Boot. All right, so let me go ahead and open up this folder right here. And this is basically our parent project. So we're going to use Maven multi-module so that we can have dependencies and then let all the submodules choose which dependencies that they need to import. And we can also enforce dependencies to all microservices. So in here, what I want to do is this folder src, we're not going to need it at this point because this is the parent module. And open up the pom.xml, and in here, so we have a couple of things, so just go through it, but basically change this according to your URL if it's not. So let me just delete that and leave the properties as is. And for dependencies, so inside of dependencies, let's just get rid of this dependency inside. So we're going to have our own dependencies in a second. And then for the build and then plugin management, so you can see that we have a bunch of plugins inside. So let's also just get rid of everything. And there we go. So let me just have the empty plugins, and there we go. Now inside, let me just have the empty plugins tag, and we're going to fill this in a second. Now, the dependency that we need in here is the following. So here I'm going to say dependency management, and then within have dependencies. And the dependency that I want in here is, so dependency, so the artifact ID. So this comes from Spring Boot dependencies, and this comes from org.springframework.boot, just like so. And then choose a version. So in my case, I'm going to pick the 257. So this version right here, I'm going to show you in a second, but this I think is the latest version as I speak. So make sure that you choose the exact same version so that you have no issues. Then what I also need is to say scope and then import. So this is using the BOM, where inside of this artifact, there's a bunch of dependencies that we can use. And this is because we're not using Spring Boot as the parent project. So this is our own parent module. And then we have submodules that can use basically these dependencies inside. So if they need, for example, the Spring Boot starter web, they can just include it right here. So this is the beauty of having the dependency management. Whereas if we have dependencies in here, so dependencies, so in here, let's say that we want every single submodule to have the Lombok dependency. So here, just say Lombok, and this comes from org.project.lombok. And let's also make sure that all submodules, they have the testing artifact from Spring Boot. So here I'm going to say Spring Boot -starter and then test. And this comes from org.springframework.boot. And there we go. So let me just put this full screen. Now, finally, because we are using Spring Boot, let's have the plugin for building the artifacts. So here, let's have a plugin, and the group ID will be com.springboot.springframework and then .boot, and then the artifact ID will be Spring Boot Maven, just like that. And also let's specify the version in here. So version, and this will come from the property. So this will be spring.boot.maven.plugin.version. And if you grab all of this and then scroll up, and inside where we have the properties, let's just paste that and then close that. And then basically what I want is to say 2.7 in here, but I just realized that this version right here is the exact same thing. So let's just take this from here and then say Spring Boot .dependencies and then version, and we can take this from here and then put it here, close that, and then inside we can say 2.5.7. and if you want, you can basically control these independently. So the Spring Boot Maven plugin as well has the exact same version, and you can see that this now is taking shape. So this should be HTTPS, And also this should be Java 17. There we go. And yeah, so this is now taking shape. So let's just basically reload the changes, and it looks like that we have an error. Oh no, that went away. But basically, if I open up Maven, so this still red. So if I clean, you can see that the process terminated. So let's have a look. So it looks like that I'm missing the type inside of the dependency management. So that's fine. So inside in here, I'm missing the type. That's for sure. And I want this to be POM. So this is so that we can use all these dependencies for our sub projects. Now let's reload. There we go. So all good. And you can see that we have the dependencies right here. Everything has been resolved. If I open up dependencies, we have Lombok and start a test. So this is what we have included, right, for our sub projects. We also have plugins, and in here, let's now clean. So I just want to make sure that this runs. And there we go. So let's validate as well. And also works. So we haven't got anything to compile, but you can see that this is working. So obviously, if you want to grab this file, you can grab it under the description of this video so that you can follow along. And all you have to do is just change the URL, the name, the group ID, and the artifact, and off you go. Now, just to recap, so we have some properties, but really dependency management. So this is so that our sub projects can pick whatever dependency that they want, and you'll see this in a second. And then dependencies, this is so that all sub modules by default have these two dependencies without them explicitly imported in their pom.xml. And then we have the exact same thing for the build. So build management right here. And basically not everything will need this Spring Boot Maven plugin. And that's why it's inside of this plugin management. If you have any questions, drop me a message. Otherwise, let's move on. All right, now let's focus on how we're going to build this microservice right here. So we're going to start with customer, and then we're going to have the RESTful API that allows us to post a customer. We also will configure the database right here. And then once we have this, then we can move into the other microservices, how they will communicate to each other, so on and so forth. But for now, let's just focus on building this piece right here, and then we can start assembling the puzzle. Now that we have this pom.xml right here, and this is the parent pom, let's go ahead and create our very first microservice as a sub module. So in here, what I'm going to do is right click in this folder right here, and this is the root, so Amigosservices or whatever you have named it. Right click, new, and then module. Now at this point, so this will be a Maven project. The project SDK will be Java 17, and don't tick anything, just say next. And right here, you pretty much name the microservice. So in my case, I'm going to name it as customer. So this will be a microservice that will deal with customers. And if I expand the artifact coordinates in here, so the group ID will be com.amigoscode, and then the artifact ID is customer, and then leave the version as is. Finish. And there we go. So now have a look. So we have this new folder right here. This is customer, and inside, so let's just open up the parent pom. And what I want you to notice is that we have now by default this new section in here, so modules, and this is a list of modules. So we can only have one module right here, and this is customer. Now, if I open up customer, so this will again have the exact same folder structure. So for any Maven project, so you have the pom.xml. So inside of this pom.xml, we have some properties, and basically have a look. The parent you can see that we have this icon. So this goes to artifact Amigoscode services right here. And I usually like to flip these around just like that. And then the model version. And then this is the artifact for this project right here, which is customer. And if I open up src main, so this is basically everything is empty, and we're going to add a few things in a second. But for now, what we're going to do is let's just open up the pom.xml for our customer microservice, and let me close this for a second. And what I want to do is inside in here, let's have, so we're going to say basically we want to have the dependencies right here, and now we can bring any dependency that we want. So for now, all I want to bring is, so I'm going to say dependency, and this has the artifact ID as spring boot dash starter dash and then web, or starter dash and then web, just like that. And this comes from org.springframework.boot. There we go. So now, so in here, have a look. So you can see that this dependency right here, it comes from, so if I click on this button in here, it comes from Spring Boot dependencies.pom, so 257. So this is what we have defined in here. Have a look. So right here, so dependency management right here, we brought all of these dependencies, and now we are letting each of these microservices choose whatever dependency that they want to use. So for this microservice, we want to be able to write a RESTful API. So hence we are bringing in this dependency. At this point, this is all we need. So what we're going to do now is, let me just close this POM and also this main POM. Oh, actually I closed the wrong one. So let me just open the POM for customer. Now inside of src, so inside of customer, src main Java, let's create a new package, name it as com.amigoscode and then customer, just like that. And what I want to do is I want to basically create a new Java class, and then I'm going to say customer application, and this will have a main method, and this class we're going to annotate it with add and then spring boot application, and here I'm going to say spring and then application dot run, and the primary source will be customer application dot class. There we go. And also we need to pass the arguments from the command line. And this is pretty much what we need. So we also need to have the application.yaml inside of resources. So here, file, and then say application.yaml, or if you prefer properties, it's completely up to you. Enter. And inside, I'm going to have server, and then I want to have the port. So I want to have control of the port, just like that. So the default is 8080. So let's say that we want this to be 8080. And we also want to name this application. So spring application name, and this will be customer. There we go. Now, what I want to do is I want to basically create a new file in here, and I'm going to name this as banner.txt, and open up Google and search for create Spring Boot banner, and click on this very first link. And in here, let's just say customer, and you can change the font if you want, but I'm just going to leave the default. Copy everything, go back, paste that in. And last but not least, what I want you to do is open up the pom.xml, and you should see this Maven button right here, or you can press Shift Command O to load the Maven changes. So we've added this dependency, so let's just make sure that this is reflected in this microservice. So if I open up, so right here we've got customer, and the only dependencies that customer has is Lombok and starter test. And this is because, so if you recall correctly, inside of dependencies, we said that we want all the microservices or all these submodules to have these two dependencies, right? But we included this one right here for this module, but it's not showing up in here because I need to reload in here. So you can reload from here or from here, either one, and you can see that you now have the dependency and it's just taking a while to index. And there we go. Now let's open up the customer application. So this is our main method, and right click, run. And there we go. So you can see that. So let me show you the logs. Have a look. So we've got our custom banner in here, which is customer, and you can see that everything started correctly. And you can see that Tomcat started on port 8080. So there we have it. We have our first microservice. Currently, it doesn't do anything. It doesn't talk to any database, so on and so forth, but we'll add that in a second. But you see how easy it was for us to bootstrap a microservice with Spring Boot. So within this package right here, com.amigoscode.customer, let's go ahead and create the model for this microservice. So this will be customer. So this is a class. And in here, I'm going to use Lombok. So every submodule has Lombok in it. So here I'm going to say add and then data. So this is Lombok and then add, and then I'll also need the builder in here. And there we go. So we're going to come back to this class in a second, but for now, this is all we need. Now here, let's have a couple of fields. So let's have the ID as an integer. Let's also have the first name and last name as a string. And finally, let's have the email in here. There we go. Now what we're going to do is, so we've got the model. So basically we're just following the n-tier architecture, and I've got a bunch of videos covering all of this stuff, how to properly organize your application, so on and so forth. So here, let's start from the controller. So I'm going to say customer and then controller. So this will be at and then rest controller. This will also need the at request mapping. And we're going to map this to API /v1 / and then customers. And I also want to have the at SLA for J, just like that. So I can just log a couple of things. And I've just realized instead of a class, let's just use a record. And because inside we're going to pass a couple of things in a second. So just leave it like that. And now let's have a public method that will basically take a customer from the request body and then register a customer. So public void register customer. This will take a customer request, and we're going to create this in a second. There we go. And this customer request will come from the request body. So at request and then body. Let's log the customer request. So log dot and then info. So new customer registration, and inside we're going to pass the customer registration, just like so. And we also need to annotate this with at and then post and then mapping, so that we can fire post requests against this endpoint in here. Now let's create this class quickly. So here, new and then Java class. This will be a record, and let's just say customer registration and then request. There we go. And what we want to pass in here is the first name. We also need the last name, and finally the email. There we go. So this is our record, and the reason why I'm using a record and not a class is because I get immutability to strings, equals, and all that stuff for free. Whereas in here, I'm actually going to use JPA in a second. Now, inside of my customer controller, so this should be actually customer registration request, just like that. Delete this, and then let's just log that instead in here, and job done. So there we go. And now let's create the service that will basically handle this request. So let's just say customer and then service, customer service, and this customer service. So let's just create this class. So create class. There we go. And let's also change this to a record and pass nothing inside for now. And if I go back in here, so what I want to do is just say customer service dot and then register customer, and then pass the customer registration request just like that. And I need to create this method in here. So there we go. And voila. So I've got the request in here. Now let's turn this request into the customer. So here I'm going to say customer equals to, and then customer dot builder. We're going to pass the first name from the request. We also need a last name, and finally email. And all we need to do is just say build. So this is the builder pattern, and there we go. Now let me just say to do here, and we're going to do this in a second. So there you have it. So basically right here, you can see that how the application is taking shape. And what we have to do next is just get the database up and running and then configure our application so that we can store the customer to our database. And finally, we need to annotate this class with add service so that Spring initializes this as a bean for us so that we can inject it in our controller. Let's go ahead and get our database up and running so that we can connect our microservice to it. So in here, what I want you to do is under the root folder of microservices right here. So Amigosservices, actually, go ahead and say new and then file, name this as docker-compose dot and then YAML, and then press enter. Now inside, I'm going to paste some YAML configuration, which you can find under the description of this video. And if you want to learn more about Docker, go ahead and check my website. I've got a course teaching you everything you need to know about Docker. But in a nutshell, so let's just start from the top. We've got services. This is Postgres. And then this is my container right here. The image is Postgres. I'm exposing the ports. And then this is the network. And right here, I've got PGAdmin. So this is the graphical user interface client. So I'm giving the name and then passing some environment variables to connect to it and exposing the port 5050 to 80 inside of the container. And right here, I've got the networks so that they can talk to each other, and then some volumes to store some data. So once you have this file, and make sure it's named as docker-compose.yaml. So you can actually run this from here if you have the Ultimate Edition. And if not, I'm going to show you how to run it through the terminal. So in here, open up your terminal or command line and make sure that you are within the project. So I'm going to type ls, and you can see that I do have this docker-compose.yaml. Now to get things up and running, just type docker space and then compose and then up and then -d for detach. Press enter, and you can see that it's creating the network. And now it's creating the containers, so the PGAdmin as well as the database. And there we go. So you can see that this was super quick. You can type docker compose and then ps, and you can see that we do have PGAdmin, which is listening on port 5050, and the Postgres, which is listening on port 5432. So now that we have this database, let's connect to it. So open up your web browser, and in here type localhost and then 5050. Press enter. Just give it a second, and there we go. So you can see that, oops, the font is too big. So now we need to set a master password. So I'm just going to say password. Right, so now let's basically add a new server, and in here I'm going to basically name this as Amigoscode, and the connection, so in here the host, this will be Postgres, And this is because we're connecting from a container to another container right here. So if I show you inside of services, have a look, networks, Postgres in here. So this guy right here uses the exact same Postgres, or the exact same network, which is Postgres. So PGAdmin uses Postgres, and right here, this is how we define the network so that these two containers can talk to each other. And if PGAdmin wasn't running with Docker, you would need to say local and then host. So this is Postgres, the port is 5432, leave the database maintenance, the username, so this is Amigoscode, and the password is password. There we go. I can save the password, and to be honest, this is it. So click on save, and you can see that we've managed to connect to our database. So I can click on it, and you can see that there is not much information in here, but basically if I expand in here, you can see that we have databases, and by default we have Amigoscode and Postgres. So now we have a database that we can work with. Next, let's configure our microservice to connect to it. So within IntelliJ, what I want to do is, let me just close all of these tabs. So close all tabs, and let's start fresh. So inside of our customer microservice, open up application.yaml. And in here, what I'm going to do is paste this configuration, and you can find this under the description of this video. And also, if you want to learn more about Spring Data JPA, you can check my website where I've got a course on this, teaching you everything you need to know about connecting to databases, joins, how to model your table, queries, so on and so forth. So it's a very in-depth course, which you should take. So in here, what I have is the data source key right here, and within it, I do have the username. So this is Amigoscode, and the URL, this is PostgreSQL localhost right here. And the reason why it's localhost is because our application right here, when we start, it's not a container. If it was a container, then we would need to connect via the network. But in here, you can see we also have the port and customer. So I'm going to come back to this in a second. We've got the password, which is password. And then here we have some configuration to set the dialect, format SQL, update when we update our entities, and then show some SQL. Now this customer right here, so this is the name of the database that we have to connect to. So if I go back to PGAdmin, inside of databases, create database, and then the owner is Amigoscode, and here let's just say customer. I'm going to say save, and there we go. So now we have this database that we can connect to it. Now the last thing that we have to do is to open up the pom.xml, and in here we brought this dependency, so start a web. So this is for RESTful APIs, but we also want the dependency that allows us to perform queries and interact with our database. So in here, let me just put this full screen, and this is Spring, and then boot, and then starter, and then JPA or Data JPA. There we go. And what we also need to bring in is the Postgres driver. So dependency, and this will be PostgreSQL, and this is from org.postgresql, and you can see that this is coming from the parent POM. And in here, I'm going to say that the scope for this is runtime. There we go. Now go ahead and basically reload. So the changes are picked up. If I open up Maven in a second, you should see that we now have Data JPA in here, as well as the PostgreSQL driver. So all good. Now let's open up the customer class, and in here we need a couple of things. So one, we need the @ and then entity annotation, and also we need @all args constructor, and also no arg constructor in here. We're not done yet, so we need to annotate this with @ and then ID, and the ID will be based off a sequence. So let's just have the sequence generator and then import sequence generator. And finally, we need to have the generated value just like so. And let's import the generated value as well as the type. So I think at this point is trying to basically have a star. So here, let me just say type. So generation type, and we are good to go. So with this in place, let's now create a new interface. So this will be customer repository. This will extend, and then JPA repository, where the entity is customer and the data type for the ID is an integer. Now what we need to do is open up the customer service, and inside of this record, we're going to inject it. So customer repository, so that we can basically save our customer. And for this to do right here, store customer in DB, let's just say the repository. So repository dot and then save, and then our customer. Job done, and delete this to do. Obviously there are more checks that we have to do, but for now, this should basically save customers in our database. Now let's start the application, and hopefully this works. And there we go. You can see that we have some logging, and here create table. So ID, email, first name, last name, and then the key is the primary key is the ID, and we also have the sequence. So this is good stuff. So now what I want you to do is to open up PGAdmin, and within Amigoscode databases, customer, and then open up schemas. So we have one schema, and this is the public schema. Open that up, and then we should have one table inside. And in fact, let me just refresh. There we go. And now if I open up tables, have a look. We have the customer table in here, and also the sequence, which is right here. So customer ID sequence. So this is really cool. So if you want, you can basically count the number of rows. So this will give you 0. So there is nothing inside, and you can even basically run queries against this. So you could say, for example, select star from and then customer, and then run this, and you can see that this gives us back. But you can see that we actually are connected to our database, and we have a table called customer based off our entity. Now what I want to do is send a post request into my API and see whether we can save a customer. So I'm going to use Postman as my REST client, and you can use any other. So in here within Postman, new request to, so this will be a post, and the URL will be localhost, and then 8080 v1 customers, select body, raw, from text to JSON, and in the body, let's have this JSON blob. So first name, last name, email, Jamila Ahmed, J Ahmed, and this JSON object right here corresponds to, so if I go back in here, so corresponds to this guy here. So if I open up the customer registration request, so it maps to this record, first name, last name, and email. So if I go back, and then let's try and send the request and see whether it works. So send, there we go, 200 status code, which means that we most likely have saved this customer to our database. So here I'm just going to rerun the exact same query and have a look. So now we have Jamila Ahmed in here. So this is beautiful, and you can see that how we now have our microservice connected to its own database. Okie dokie. I hope that you had fun learning about all of these different things, and you saw that how We are structuring things nicely with Maven multi-module using dependency management, so on and so forth. Now, what we have to do is, so we have customer right here. And in the next video, what I want to show you is how we're going to set up fraud microservice as well as the notification microservice. And we'll also stick in the distributed tracing, so you see how the request flows from these different microservices, right? And also you'll see how we're going to build the client so that we can interact with these microservices, as well as set up the Eureka server and setting each of these microservices to register as a client. If you enjoyed what you saw, comment down below. Literally comment down below. Let me know what you liked, any suggestions that you might have, and also don't forget to smash that like button so I can keep on recording these videos. If you're not part of the Amigoscode community, go ahead and join. The community is growing on Discord as well as private Facebook group. I would love to see you there. This is all for now. I'll catch you on the next one. Assalamu alaikum.